All right, guys, so I'm gonna make a quick video on how to get that multiple regression one. This is all the stuff. This is all my variables up here. So all these are the variables. Now I'm gonna go down to here. I'm gonna reopen back up my proc core. I need my proc means, obviously. Let me go ahead and comment this out real quick too, just because I don't want to be all janky with it and have it take forever, because it does already take forever. So I'm going to go ahead and erase all this. So the very first step we're always going to do is do the stepwise selection process, which is right here. If you notice in these variables right here, I took out status. Let's see. Yeah, I took out status and follow-up days because that's only relevant for the either the life test or the hazard ratio. So I don't even include those in the multiple regression. Just make sure you guys pay attention to that. So after I run that, that's probably the mistake anyone made, because I made that mistake at first too, but then I thought about it and it didn't make any sense. So I'm just going to go ahead and run it. And like I said, this one takes forever. So hopefully it works the first time. Am I going to get lucky? About to find out. Okay, I did get lucky. Okay, good. So now we're going to go to this one, step one. Just going to go through this process. I took all these variables and I wrote them. I wrote anything that was collinear down, so I knew I wouldn't include those. And in this case, the definition is less than 0.05. So even this one would be considered collinear. This one is considered collinear, just a heads up. So this one, I entered all of these variables. All these variables were entered according to the stepwise selection. Doesn't matter if they're collinear or not at this point. We're going to enter them into the reduced model, but we will take them out later. And so then, boom, ran the adjusted R squared. So I'm going to go ahead and run those here. Put more this bad boys there. Take out these, and then I'm going to run the adjusted R squared. And then I'm going to use the adjusted R squared to figure out which ones I actually need to input into my final model. So then I'm always going to start off with the best one, which in this case, the best one was albumin, whatever that word is. This one right here. And so then I find the best two that includes albumin. So the best two is albumin and sex. Yes, it is. Albumin and sex, which is 0.1068. And then this one was 0.0498. So it is an improvement of more than 0.05. So we're safe there. The next thing I'm going to do is to make sure that they're not collinear. So sex with albumin, so right there, it is 0.1344, which therefore means we are not collinear. So then we're going to go to the best three, including both of those two. So it looks like there's a 3 right there with it. There's a 3 right there with it. And the highest 3 with albumin and sex is 0.1111. So we cannot add it. So we're only going to add albumin and sex into the final model, which is right there. And then there we go. Then we're going to run that model. And then here's your adjusted R squared right there. So it's going to account for 10.68% of the variance. Both of those variables do. Here they are right here. Here's your parameter estimates. right there. So those are your coefficients in front of the variables albumin and sex, and there is your intercept. Right here is your adjusted R squared value. So that's your percent of variability. And then this one right here is what you're going to use for homogeneity of variance. And I don't really know what I would say with this one. It seems like it's pretty heavy, so I would almost say it's like a C or like a raindrop. So I would say there's a pattern to it, but I'm not sure what to call it because this one was always unclear to me. So if someone can clear that up, that'd be amazing. This right here is what we're going to use for normality. It does this form a straight line. I don't know what you would say there either. I would say yes, it is a straight line. So that's my thing. And then it is independent. So that's just kind of all of those right there. Yeah, there you go. So if we need to include outliers, make sure you just add influence right there. Or sorry, R influence. And that should give you the list of like Cook's D and DFITs and HStat. Let's see if it did. I hope it did. Because if it didn't, I don't know what to tell you. It did. Okay, good. Yeah. All right. So yeah, if you need outliers, that's what you write down for that one. Hopefully she doesn't have us do that. We'll probably just have to calculate with the H statistic in the Cook's D, which is all Cook's D is always 1. H stat is the one that's without the square root, and the one with the square root is DFITs. So just a little heads up on that. Hopefully that helped you guys out a little bit. Okay.